So, hello student, here in this lecture we are going to see the last method to study the order of reaction. Okay, and this method is a post-Watts isolation method. This is the fifth method by which we are studying the order of reaction. So what we are doing here, see, we are considering one general reaction, M moles of A, N moles of B gives you the product. Okay, now M is the order. We can say M is the order with respect to A, and N, small n, is the order with respect to molecule B. So rate of reaction is given by, okay, see, this is a constant, rate constant into concentration of A raised to M. Okay, now this is concentration of B raised to M, and as we know that what is order of reaction, it is a sum of the concentration terms raised. So M plus N, this is what the total order of reaction. Okay, so for this reaction you can find out the order by making sum of M and N. This is what the M and N. Okay, now, so what this method involve actually? So one of the reactant is taken in a small quantity and other is taken in excess quantity. We are doing in inverse way for the next time. See, it involves the one of the reactants. See, by A by keeping its small concentration while concentration of B is very large excess. So rate of the reaction will not get affected by the concentration of B, but rate will depends upon the concentration of reactant A. कारण त्याचं concentration कमी आहे आणि B चं खूप जास्त आहे. म्हणून त्या केस मध्ये आपण काय म्हणूयात की rate is equal to K dash into CA raised to M. Okay, concentration of A जो आहे त्याच्यावरती रेट टोटली डिपेंड आहे असं म्हणूया. नेक्स्ट केस मध्ये काय करायचं आहे आता, कॉन्सन्ट्रेशन ऑफ बी थोडं घेऊयात आणि कॉन्सन्ट्रेशन ऑफ ए विल टेक इन अ व्हेरी लार्ज एक्सेस. ओके, सो व्हाट विल हॅपन ओव्हर देयर, इट इज टेकन इन द लार्ज एक्सेस, राइट? सो टोटली रेट विल डिपेंड्स अपॉन द कॉन्सन्ट्रेशन ऑफ बी ओनली. ओके, नॉट ऑन द ए. Where we have seen this is in the pseudo first order reaction. Pseudo first order reaction, तिथे पाण्याचं कॉन्सन्ट्रेशन जास्त होतं आणि मिथिल ऍसिटेटचं कॉन्सन्ट्रेशन कमी होतं, बरोबर ना? ते आपण त्या ठिकाणी स्टडी केलेलं आहे. फर्स्ट एक्झाम्पल ऑफ pseudo first order reaction. मग आता ह्या केस मध्ये, सेकंड केस मध्ये रेट कशावर डिपेंड आहे? कॉन्सन्ट्रेशन ऑफ बी, बिकॉज दॅट इज टेकन इन व्हेरी स्मॉल कॉन्सन्ट्रेशन. ओके, सो रेट इज इक्वल टू K डबल डॅश CB raised to N. Okay, so total order of reaction is calculated by making the sum of M and N. Okay, so total order of reaction is here M plus N, M plus N. This is what the post-Watts isolation method. In simple, एका reactantचं concentration कमी घ्या आणि दुसऱ्याचं large excess मध्ये घ्या. मग ज्याचं concentration कमी असेल त्याचा उपयोग करून त्या ठिकाणी आपण order of reaction find out करतो. ठीक आहे? Now see, this is an example for that. ही general reaction आहे. MA gives you the product. ओके, आता इथे जर तुम्ही ऑब्झर्व केलं, ह्या एक्झाम्पल मध्ये काय केलं त्यांनी, 3 सेट घेतलेले, सेट 1, सेट 2 and सेट 3. ओके, आणि त्या ठिकाणी कॉन्सन्ट्रेशन दिलेलं आहे. These are the concentrations of A and these are the concentrations of B. And these are the corresponding rates. These are the corresponding rates. Okay, now see. Now we are going to find out the order of reaction with respect to A and B. Okay, now see. The general rate equation, what we have? Rate is equal to K into CA raised to M into CB raised to M. Concentration of A raised to M, concentration of B raised to N, where M and N are the order with respect to A and B, that we have already seen. Therefore, order of reaction is, we have general equation that we are using here again. N is equal to log of dx upon dt1 minus log of dx upon dt2. Here log is missing. Okay, then that again, 1 minute, let me clear it over here. That may leads to the confusion. Okay, See here now. Okay, so in the set 1 and second, in the set 1 and set first and set second, the concentration of B is constant. Concentration of B is constant in set first and set second. Okay, and change in rate will due to the concentration of change in concentration of A, है ना? या A चं concentration पहिल्या सेट मध्ये किती 0.10 आहे, दुसऱ्या सेट मध्ये किती 0.30 आहे. बघा या ठिकाणी आपण व्हॅल्यू एंटर करूया. M is equal to log of dx upon dt2 minus dx upon dt1 upon log of c2 minus c1. So see, dx upon dt2 minus dx upon dt1. So this value minus this value. Okay, this value minus this value. Now log of 0.096 minus log of 0.0032, right, upon log of 0.3 minus log of 1. So log of this value 0.3 minus log of 0.1. So what is the answer? You get the answer as a 1. By solving this, you get answer as a 1. Now we'll see second case. Now we'll see in the second case, here concentration of 1 is constant in set 1 and set 3. But the concentration of B is different. In set 1, concentration of B is 0.10 and concentration of B in set 3 is 0.20. Okay, so we are considering these two rates. Okay, this rate minus this rate is log of this minus log of this value upon log of this value minus log of this value. See, here it is. Dx upon dt3 minus dx upon dt1, right? C3 log of C3 minus log of C1. See, 0.0064 minus log of 0.0032. Yeah, 0.0064 minus log of 0.0032 upon log of 0.2 minus log of 0.1. So log of 0.2 minus log of 0.1. Okay, so you get the answer 1. So total order is m plus n, that is 1 plus 1. Here this is what the value of m. Okay, and this is what the value of m is equal to 1, right? So making the sum of this one and this one, you will get total order as a 2. This is what the Ostwald's isolation method. Again, I am repeating, one of the reactant is taken in excess while other is in the less concentration, and the reactant which is there in the less concentration to find out the order of reaction. Okay, thank you. This is what your whole topic, chemical kinetics. Okay, apart from, so I'm just reminding you what we have studied here. We have studied order of reaction, then molecularity of reaction, okay, the rate of reaction. After that we have studied first order reaction, then second order reaction, then pseudo first order reaction. Okay, after that we have studied different methods to find out the rate of reaction. 5 methods are there. Okay, so all that 5 methods we have studied over here. So next topic will start from the next session. Thank you.